Jai Hind, dear students, we are going to study the chapter 15, Introduction to Graphs.
Introduction. Usually data can be presented in the form of table. Graphs are visual representation of data. In this chapter, let us study histogram and line graph. New channels and magazines use graphs to give a better understanding of the article. Graphs provide a catchy and simple way. Here is a pie chart that clearly compares the sales of a magazine in various countries in the world. Thus, the graphs play a very important role in our lives. Objectives. At the end of this lesson, you'll be able to draw bar graphs, represent the given data in the form of a pie graph, draw histogram, draw line graph, locate a point on the graph, solve some application problems using graphs. Graphical representation. Bar graph. It is a pictorial representation of the numerical data by a number of bars, rectangles of uniform width erected horizontally or vertically with equal spacing between them. The bar graph shows Divya's performance in the quarterly, half-yearly and annual examinations. It helps us to compare whole year's performance. From the above graph, we infer that Divya's total marks has been increasing, which shows progress in her studies. Bar graph can also have double bars. This graph gives a comparative account of sales of various crackers over a 2-day period. From the above graphs, first graph shows the comparison of 3 examinations of a student. Second graph shows that 4 variety of crackers sales in 2 days. Pie graph or a circle graph. Pie graph is used to compare parts of a whole. The circle represents the whole is a pie graph. In the month of December 2008, Ramu spends his monthly salary amounting to Rs 7,200 on different items. Histogram. A histogram is a graphical representation of a frequency distribution in the form of rectangles with class intervals as bases and heights proportional to corresponding frequencies such that there is no gap between any 2 successive rectangles. The following table gives the marks scored by 100 students in an entrance examination. A line graph. A line graph displays data that changes continuously over periods of time. The above table shows the temperature of Chennai city, taken every 4 hours for a day. We call this as time temperature graph. The horizontal line x-axis shows the timings at which the temperatures were recorded. The vertical line y-axis denotes the temperature. The temperature of every 4 hours is recorded and plotted as points as shown in the graph. These points are connected by line segments. The result is line graph. From the graph, in between 10 a.m. and 2 p.m., we can find that the temperature was increased by 2 degrees Celsius. This is the location time graph for a cyclist. While plotting the graph, the short movements of time where the cyclist changed his speed when neglected. From the graph, we can determine the location of the cyclist at a given movement. The type of motion with which he was traveling along particular segments is speed, the distance he covered, and even his direction of movement. So from segment AB, we can discover that the cyclist covered the distance of 100 meters in 20 seconds, moving at a constant speed of 5 meters per second. Segment BC indicates that the cyclist stopped after having traveled a distance of 100 meters. From segment CD, we can see that the cyclist went on to move with a greater speed. In 20 seconds, he covered a distance of 200 meters, which means that he was traveling with a speed of 10 meters per second. Segment D shows the cyclist stopped for 20 seconds. Then from segment EF we can discover that the cyclist turned back and after 20 seconds reached the location which he started his journey. He was moving with a constant speed of 15 meters per second. Coordinates. Locate the seat in your class. For this you need to know two numbers, that is the row number and the column number. For example, 3, 2, which is 3 units from the left edge and 2 units from bottom edge, is plotted on a graph sheet. In a graph sheet we draw x and y axes conveniently and then fix the required point. 3 is called x coordinate of the point. 2 is the y coordinate of the point. We say that the coordinates of the point are 3, 2. Always the first number indicates x coordinate and the second number indicates y coordinate. Example. Plot the point 4, 5 on a graph sheet. Is it same as the point 5, 4? Solution. Locate xy axes. Start at O, 0, 0. Move 4 units to the right, then move 5 units up. We reach the point 4, 5. From the graph the points 4, 5 and 5, 4 are different points. Line graph. A graph obtained by joining the plotted points in a line. Such graphs are called linear graph. Application problems. In everyday life we heard about the fact that global rise in fuel prices leads to petrol price hike. If less petrol is consumed, then the bill amount will be less. This means that one quantity affects the another. Petrol bill depends upon the quantity of petrol consumed. We say that the quantity of petrol is an independent variable and the amount of petrol bill is the dependent variable. The relation between such variables can be shown through graph. Example, quantity and cost. The following table gives the quantity of rice and its cost. Plot a graph to show the data. 1. Mark the number of kgs of rice in x-axis, horizontal axis, with 1 unit is equal to 5 kgs. 2. Mark the cost of rice in y-axis, vertical axis, with 1 unit is equal to rupees 100. 3. Plot the points 10, 300, 15, 450, 20, 600, 25, 750. 4. Join the points. The graph passed through the origin. Suppose we want to know the price of 17 kgs of rice. Locate 17 on horizontal axis, then follow the vertical line through 17 till you meet the graph at P. From P you take a horizontal line to meet the vertical axis at 475. This meeting 475 point provides the answer. This is a graph of situation in which two quantities are in direct variation. The graph will always be linear. Example, principal and simple interest. A bank gives 11% simple interest on deposits by senior citizens. Draw a graph to illustrate the relation between the sum deposited and simple interest earned. Find from your graph 1. The annual interest obtained for an investment of rupees 500. 2. The investment one has to make to get an annual simple interest of rupees 88. Solution. A. Mark the deposit in rupees. On x-axis, horizontal axis with 1 unit is equal to rupees 100. B. Mark annual simple interest in rupees. On y-axis, vertical axis with 1 unit is equal to rupees 10C. Plot the points 500, 55, 666, 777, 888, 999, 1110. D. Join the points. Usually data can be presented in the form of table. Graphs are visual representation of data. In this chapter, let us study AB. we get a graph that is linear. 1. For rupees 500 on x-axis, we get interest to be rupees 55 on y-axis. 2. For rupees 88 on y-axis, we get the deposited amount rupees 800 on x-axis. Example: time and distance. Akshay can ride a car constantly at a speed of 40 km per hour. Draw time-distance graph for this situation. Use it to find 1. Time taken by Akshay to cover 160 km. 2. The distance covered by Akshay in 2.5 hours. We get the table of values. Scale: x-axis 1 unit is equal to 1 hour. Y-axis 1 unit is equal to 40 kilometers. A. Mark time on horizontal axis. B. Mark distance on vertical axis. C. Plot the points 1, 40, 2, 80, 3, 120, 4, 160, 5, 200. D. Join the points. We get a linear graph. 1. In vertical axis, 160 kilometers corresponds to 4 hours in horizontal axis. 2. In horizontal axis, 2.5 has correspondence to 100 kilometers in vertical axis. Therefore, Akshay covers 160 kilometers in 4 hours, and in 2.5 hours, he is able to cover a distance of 100 kilometers. Summary. Let us summarize what we have learned. A pictorial representation of data is a graph. A bar graph is used to compare among categories. A pie graph is used to compare parts of a whole. A histogram is a bar graph that shows data in intervals. A line graph displays data that changes continuously over periods of time. A graph obtained by joining the plotted points in a line. We need x-coordinate, y-coordinate for fixing a point on the graph. We can show direct variation through line graph.
Welcome to Math for Juniors with me, Miss Marks, and my assistant Snail. You look lost, Snail. What are you thinking?
Oh, hi. I'm thinking about our phone bill.
What happened? Was it high this time also?
Yes.
Oh, your dad must be really upset, huh?
Yeah. In fact, he has strictly told all to talk less on phone.
Of course. The less you talk on phone, the lesser will be your phone bill, and vice versa. Hey, there's a linear relation between them. You know, you can represent such linear relationships on graphs. These graphs are nothing but linear graphs.
Breathe, Miss Marks. Math is making you too fast. Now, what's this linear graph?
Recall, Snail, a linear graph is a whole unbroken line.
I seem to recall a little.
Oh, Snail, before you annoy me further, let's see some examples of common linear graphs today in the virtual world. Let's begin the module with this illustration. New York is about 12,952 kilometers away from Mumbai, and it takes 16 hours to reach there by a non-stop flight. Is it possible to know how far one would travel each hour? If we assume that the Mumbai-New York flight is non-stop and flies at a constant speed, then distance-time graph can help us know that. Wondering how? Let's find out in this module on linear graphs, where we learn to plot some specific linear graphs like distance-time graph, quantity versus cost graph, and finally, principal versus simple interest graph. In distance-time graphs, time, being independent variable, is taken on the x-axis or horizontal axis, and distance being dependent variable is taken along y-axis. The total distance of 12,952 kilometers is covered by the non-stop flight in 16 hours. Assuming that the flight moves at a constant speed, the flight approximately covers 810 kilometers in an hour. So in 2 hours' time, flight will travel 810 plus 810 is equal to 1620 kilometers. In 3 hours' time, it is 2430 kilometers, and so on. We can make a tabular column where we list this distance time data. On y-axis, mark the distance using a scale of 1 unit equal to 810 kilometers. Appropriately, along x-axis, each unit can represent 1 hour. Now plot the points: 1 hour 810 kilometers, 2 hours 1620 kilometers, 3 hours 2430 kilometers, 4 hours 3240 kilometers, 5 hours 4050 kilometers, and 6 hours 4860 kilometers. On joining the points thus plotted, a straight line or a linear graph is obtained. Straight line between distance and time implies that these two quantities, distance and time, are in direct variation. For example, at 2.5 hours, the flight would have traveled through 2025 kilometers. Similarly, at 5.5 hours, the flight would have traveled through 4,455 kilometers. Hence, we can employ the distance-time graph to predict the distance travelled by a body moving at a constant speed at a given instant of time.
Wow!
Why are you laughing?
I am thinking there is a linear relationship between the food I eat in the canteen and the bill I have to give. I can plot that on a graph too.
You're right, but that's not funny, Snail, huh? Anyways, let's go to the virtual world and see another example of linear graph. It's a common experience that more the quantity one wants to buy, more one has to pay. This logic holds true for any commodity available in the market, be it sweets, books, or anything. Mama has bought apples. She paid rupees 100 for 1 kilogram of apples. She was told by the fruit seller that there is no discount on the price of apples, whether she buys 1 kg or 10 kgs of apples. So for 2 kg of apples, the price will be rupees 200. For 3 kgs, it is 300, and so on. In this data, the quantity of apples is the independent variable and price is the dependent variable. So, while we plot the graph between quantity versus cost, we can represent the cost on the y-axis using a scale of 1 unit equal to rupees 100 and the quantity on the x-axis using a scale of 1 unit equal to 1 kg. Plotting the points 1, 100, 2, 200, 3, 300, so on. And then joining them gives straight line graph between the quantity and the cost of apples. From this graph, as we did earlier, for any given quantity, we can know the total cost of apples or vice versa. It appears to me you're not in mood to study today,
No, I am.
Okay, then tell me what's the relation between simple interest and principal?
That's a tough one. I wanna learn.
Okay, then let's learn that in the virtual world. Bank deposits are considered to be safest form of savings. We earn simple interest on the principal amounts invested in the banks. Recall the relation between amount invested and simple interest earned. It is SI is equal to PRT upon 100, where SI is the simple interest, P is the principal amount, R is the rate of interest, and T is the time duration for which the amount is deposited. Clearly, the two quantities SI and P are in direct proportion. For a deposit of 1 lakh and above, the bank offers 11% simple interest per annum. So, if the amount is 1 lakh, then the amount of interest earned will be 11,000 rupees in a year. For an amount of 2 lakh rupees, interest earned would have been rupees 22,000, and so on. Now, in order to plot the graph between SI and P, principal amount P is taken on the x-axis and the simple interest SI is taken on the y-axis using. On plotting the points 1 11,000, 2 22,000 and 3 33,000 and so on, and joining them, the simple interest and principal graph comes out to be a straight line graph. Thus, it's possible to find the cube root of a given algebraic expression.
Plotting graphs makes things so easy.
Right, Snail?
I was wondering whether these graphs go under algebra or geometry.
Well, this is algebra only, but in higher math, there is a special branch of math called graph theory. There is an interesting story behind the foundation of this branch.
Story? I love stories.
Great. Then let's check out in the Do You Know section. Do you know that a problem related to a city named Königsberg in Germany laid the foundations of graph theory in the year 1735?
How?
The city is built around the junction of two rivers. 7 bridges were built to connect the parts of this city on both sides of river for people's commutation. Some people tried to discover a path through the city which would cross all 7 bridges only once but never succeeded. Later on, this problem came to the notice of Swiss mathematician Leonardo Euler.
So, did Euler find the path?
Well, he simplified this problem by representing each landmass as a point and each bridge as a line, and ultimately concluded that the problem had no solution since each landmass has odd number of edges. While doing this, he laid foundation of what is now called graph theory.
Oh, that's amazing!
Now, why don't we take quick memory jog and revise everything we have learned today? In this module, we have learned the following. A line graph, which is the whole unbroken line, is called a linear graph. A linear graph can be plotted by taking the independent variable on the x-axis and dependent variable on the y-axis. Two quantities which vary directly can be plotted as a linear graph. A linear graph can be interpreted to find out the relation between two quantities.
Miss Marks, I need to leave now. I have to complete a geography project.
Okay, but first we have to say bye to our friends,
We will see you soon again.
Hello friends, Welcome to Math for Juniors. I'm Miss Marks and here is my assistant Snail.
Hello, friends.
What did you do on the weekend, Snail?
Oh, Miss Marks, I prepared a chart that represents the number of chocolates I ate.
And what did you call this chart?
A chocolate chart, Miss Marks.
Oh, you know what, Snail? Your chocolate chart, if plotted on a graph, will make a linear graph.
One more term. Linear graph. I want to learn about it.
All right. Then today, let me teach you plotting of linear graph. So, into the virtual world. Let's begin the module on plotting a linear graph. Little boy is on his way to visit his aunt. At noon, the odometer measures the distance traveled by his car as 50 kilometers. His car had been moving at constant speed of 50 kilometers per hour. At 1 p.m., his odometer reads 100 kilometers. The little boy is listing down the distance traveled and time displayed on a paper. 50 kilometers, noon. 100 kilometers, 1 p.m. 150 kilometers, 2 p.m. 200 kilometers, 3 p.m. Now he wonders if he could plot these points on a graph sheet. What will be the shape of this graph? Let's find this out in this module, Plotting of a Linear Graph, where we learn about linear graphs by plotting them on a graph sheet and to identify dependent and independent variables in a graph. Let's see how the little boy plots the graph out of the data of distance traveled and time taken by his car. He draws two perpendicular lines to represent the x and y axis. Distance d in kilometers is taken on the y-axis and time t in hours on the x-axis. On the vertical axis, that is y-axis, choose scale as 1 unit is equal to 50 kilometers. Now we plot the points on the graph. Mark a dot corresponding to 50 on the vertical axis and noon on the horizontal axis. Similarly, the second dot for 1 p.m. along x-axis and 100 kilometers along y-axis. Third dot for 2 p.m. and 150 kilometers. And fourth dot for 3 p.m. and 200 kilometers. Now join all these dots with the help of a ruler. Extend the straight line to the back, right till the origin. Such an unbroken straight line graph is called a linear graph.
Yeah! Now I will draw a linear graph for distance I travel every day.
Yes, that graph will exactly look like this. I have never seen you walking, so obviously your graph will be blank.
That's not true. I walk around an hour to reach here.
For 2 kilometers, you walk 1 hour. That's really slow.
Slow? That's wrong again. It is because I take many breaks on my way.
Got you, Snail. Now you realize, Snail, you are considering the time only. Think about the distance also. They are related to each other.
Related? How?
Aww, don't be confused, Snail. Let's enter the virtual world to clear your doubts. In a linear graph, there are two variables that are compared. one variable which changes and the effect of this change is seen on the other variable. So, the second variable depends on the changes in the first variable. Here, the first variable is called independent variable and the second is called the dependent variable. Conventionally, the independent variable is represented along the x-axis while the dependent variable is taken along the y-axis. In the distance time graph, the distance covered depends on the time taken. So, here the distance is the dependent variable and the time is the independent variable. Little boy is curious to know by looking at the linear graph that what distance he would have covered by 2:30 p.m. Well, it's simple. Take the midpoint between 2 p.m. and 3 p.m., that is 2:30 p.m. along the x-axis. Now, drawing the vertical and horizontal line corresponding to this midpoint, the distance covered is 175 kilometers by 2:30 p.m.
I was wondering, Miss Marks. We are learning this, but what are the uses of a linear graph?
Don't stress your small brain cells too much, Snail, huh? Let me impart some knowledge here. With a linear graph, specific values of the variables can be found. That is, if one value is given, it's easy to determine other.
Oh, it's really helpful.
Correct. Let's enter the virtual world to know more. Let's plot the graph for the side of a square and its perimeter. Recall that the perimeter of a square is 4 into length. So if the length is 1 centimeter, perimeter will be 4 centimeters. For side length 2 centimeter, the perimeter will be 4 into 2, that is 8 centimeters. If the L is equal to 3 centimeters, then perimeter will be 12 centimeters and so on. Now, plotting these points one by one, and joining them gives a linear graph. The graph of two quantities is a linear graph if the two vary directly. Here, the ratio of perimeter to length is a constant 4. In a linear graph, the ratio of the y-coordinate and the corresponding x-coordinate is a constant. This is an important point to remember.
Point noted, Miss Marks.
Great!
Miss Marks, I was wondering, like chocolate graph, can we have chocolate graph paper?
Chocolate graph paper? Won't you eat that, Snail, huh?
I might, but it sounds so cool. Is there any variety in graph paper available, Miss Marks?
Wow, your food really gives you good ideas sometimes, huh? There are many types of graph paper available. So let's check out our Do You Know section. Do you know that there are about 8 different types of graph paper available?
8?
Yes. Let me start by showing you quad paper. Quad paper is the most common type of graph paper with a sparse grid printed in the light blue or grey.
Oh!
Second form is engineering paper. It's generally printed on light green paper.
Oh!
Then, Snail, there is something called as Genko Yoshi paper.
Genko Yoshi?
Genko Yoshi is a type of manuscript paper used in Japan. It's used for writing horizontal scripts. Then we have hexagonal paper.
Oh, it shows regular hexagon instead of squares.
Used to map geometric designs. Then we have an isometric graph paper, also known as 3D graph paper. It has series of 3 guidelines forming a 60-degree grid of small triangles.
Looks interesting.
Then there is one normal probability paper with rectangles of various widths. Lastly, we have polar coordinate paper having concentric circles divided into small arcs. It's time to run along and take a memory jog to refresh our understanding of linear graphs. In this module, we have learned following. An unbroken straight line is called a linear graph. Generally, independent variable is taken on x-axis and dependent variable is taken on y-axis. So friends, with this, we have come to the end of our show. See you guys later in another episode of Math for Juniors. Till then, take care. Goodbye.
Bye!
Dear students, in today's class we discussed bar graph, pie graph, histogram, line graph and linear graphs. How to locate the points in a plane, how to identify the coordinates and how to draw the graph. All the things are clearly discussed in today's video. So for you, now the time is to practice by doing more examples and exercise problems from your textbook. Also, read the textbook very clearly and understand all the important points. Students, it is very important to practice all the examples provided in your textbook. That is, examples from 1 to 8. So all of you practice those examples very well and understand the concepts very clearly. After practicing the examples, you need to complete the homework from exercises 15.1, 15.2 and 15.3 so that you will get all the ideas about all the graphs mentioned in this chapter. Okay children? So that is the end of the chapter. Wish you all the success, work hard and do a sincere revision and good practice. Complete all your pending notes and homework and make your lessons up to date. Prepare well and study well, and all of you want to score top marks in the examination. That is all for today's videos class. Meet you in the revision time. Thank you children.